Hello friends, this video on P block elements part 3 is brought to you by examfear.com. No more fear from exam. So let's see the trends for P block specific. We'll talk about electronic configuration, atomic and ionic radius, ionization enthalpy, electron gain enthalpy, electronegativity, metallic character, oxidation states. We'll discuss about all these things in detail. So let's start with the electronic configuration first. So if you see the electronic configuration, these are my P block elements, right? My electronic configuration is Ns2 Np126. That is my electronic configuration. For example, if you talk about boron, this becomes what? 1s1, 1s1, sorry, 1s2, 2s2, and 2p1. See, 2 plus 2, 4 plus 1, 5. This is my electronic configuration. If you see, if you ignore this, the last part is what? Ns2, Np1. Similarly, carbon, if you talk about, there's 1s2, 2s2, 2p2, 2, 4, 6, 6. Correct. So if you ignore this part, this is what? Ns2, Np2. It is following this part. Similarly, if you talk about the neon, 1s2, 2s2, 2p6. So if you ignore this part, the electronic configuration is Ns2, Np6. That is my typical electronic configuration for P block element. We talk about the atomic radius. Before that, let's again discuss the types of atomic radius. We have discussed this in class 11. So there is something called van der Waals radius. So this is the radius of the imaginary hard sphere, which can be used to model the atom. It's an imaginary hard sphere. For example, these two atoms, and they're bonded by a weak van der Waals force, right? Actually, there is no real bond. There is no chemical bond between them. There's just a strong force of attraction between these, right? This is just a weak force, you can say. Weak force of attraction. So thus, this radius is my van der Waals radius. So to find the distance between two nucleus, divide by 2, you get van der Waals radius. But in this case, if you see, there is no bond as such, right? It's just a weak force of attraction between them. And thus, you get this whole thing as my van der Waals radius. The next is the covalent radius. In this, if you see, they are little more closer together, right? Because there's a bond here. This is a bond. There is a bond between them. Weak force, no bond. So in this case, there's a bond. These two nucleus comes together, and this distance is my covalent radius. If you see, for the same molecule, if you take, or same atom, if you take, you can find the van der Waals radius, you can find the covalent radius, and these radius will differ. Correct? And there is something called ionic radius also. So in case a compound or in case an atom is not forming a covalent bond, is forming ionic bond, for example NaCl, they don't have a there's no covalent bond in this. Electron is actually transferred, right? So we form an ionic bond. So in this case, we talk about ionic radius. But again, in this case also, we have a bond, right? We have an ionic bond between them. Correct? So we have three kinds of radius. The van der Waals radius, which is nothing but radius of an imaginary hard sphere, right? It's all imaginary hard sphere, and there is no bond access between them. They're just held by a weak force of attraction. Then we have my bonded radius, either covalent radius or ionic radius. So there's so many different kind of radius, and these values differ. For example, in this case, for a given atom, if you see, the van der Waals radius is 180 picometer, right? But if you talk about my this radius, 198, sorry, 99 picometer is my 99 picometer is my covalent radius or ionic radius, and 180 picometer is my van der Waals radius. Why? Because you see, if you talk about the van der Waals radius, I am talking about just in these two molecules, there is a force of attraction between these two. You see, there is no bond between this unit and this unit, right? They're just a force of attraction, the van der Waals force of attraction, and then you find the radius. But if you talk about the actual reaction, because here, if you see, actual bond formation has taken place, and then you find the radius, that becomes a covalent or ionic radius. So if you see, if you talk about the covalent atomic radius for group P block elements, this is how the trend is. If you go down the group, the atomic radius increase. If you go from left to right, the atomic radius decrease. Why? the nuclear charge increase, right? It's more and more charge, more and more charge, right? More and more charge, more and more charge in the atom, the nucleus actually, I'll say. More and more charge. The more and more charge, these charge will attract these electrons and the atom will change. Correct? There's less charge, so it will not attract the electrons so far, so vigorously. So the electrons will be in the outermost shell. But in this case, since it has more charge, it is like this. The nucleus is the head member of the family, right? And the nucleus attracts these electrons, they'll come together. Same thing, if the nucleus attracts, all these electrons will come together and the size will shrink. If the nucleus is careless, it doesn't have much power, all this electron will wander around. They'll move from here to there, right? That's a similarity you can say. So that's why if we go down also, the nuclear charge increase in this case also, but the number of electrons also increase, right? So the number of electrons this nucleus has to handle is more. Even if the nucleus is more powerful, if you talk about the power per electron, if you talk about that, because the number of electrons have increased, that will decrease. Correct? It's about this. There's one manager and handling one person, and 10 managers. The manager is more powerful. So it's all that. It's all the capacity of this nucleus to attract and the number of electrons. So based on these, this is the trend. So if you want, you can again watch my previous videos where we discussed these in more detail, why we have this kind of trend. If you see boron, carbon, nitrogen, oxygen, fluorine, if you go from left to right, the size is increasing 82, 77, 75, 73, 70, 169. The value is decreasing. If you go down, 82, 118, 126, 114, 148. In this case also, it is increasing. These values are in picometer. Right? And then the concept of atomic radius come. You must have seen these term. Why I'm discussing these again is a lot of students get confused between the van der Waals radius, covalent radius, ionic radius, and atomic radius. See, atomic radius is an empirical value. It's experimental value. So what happened is this guy J.C. Slater in 1864. What he did was he did a careful comparison between the bond length of over 12,000 bonds types in ionic, metallic and covalent crystals. For example, if you talk about the hydrogen itself, right? So hydrogen sometimes form bond with carbon. So sometimes hydrogen form bond with oxygen. Sometimes hydrogen form with nitrogen, right? So these bonds, or sometimes you have only hydrogen. So these bond lengths for hydrogen in all these cases will differ. Right? When you talk about the bond length, yes, because the bond length again will depends on the amount of attraction between the carbon hydrogen or the hydrogen oxygen or nitrogen hydrogen, or if you talk about the phosphine, phosphorus hydrogen. So what this guy did was he did an experimental study. I mean, he noted down all the bond length and he found the average for hydrogen. For most of the he found the average. What is the average? You add these and take more and find the van der Waals radius, covalent, ionic. He found everything for hydrogen and just found the average. Same thing he did for other elements also. So he found the average of the bond length, right? Because if you see the same hydrogen, it depends on this ionic, metallic, covalent, the value is different. This is more of empirical data, and he made a chart for that. Right, for all the elements he found the bond length, and that length is used as a atomic radius because that is more true value in the sense that it covers all the different type of hydrogen bonds or different type of oxygen bonds or carbon bonds, right? So that's more of experimental data. Correct?
Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.